So when we talk about Docker, the first thing that comes to our mind is Docker images and Docker containers, isn't it? These are the swag words that everyone wants to showcase. But having said that, you might have seen this image a million times describing the architecture of Docker. We have already covered this in depth in the Cracking Docker episode, so please check it out if you need the details of how Docker works internally. We will not be going over that same again. But just to give you the context, when we compare Docker with virtual machines, you need to understand that virtual machines provide you an abstract form of your hardware, with each virtual machine having its own guest operating system, where you can set up your application server. Whereas in Docker, you bind your application and libraries with the OS distribution into an entity, which in runtime is also known as a container. And you run it on the shared Linux kernel, which basically runs on the WSL2 utility VM. And that is why you can run different Linux distributions even though you're working on Windows or Mac. Yes, the computer that you have right now, you have installed Docker, might be Windows or Mac, but you can still run multiple containers with multiple Linux distributions. And this gives us the benefit of lower cost both in terms of time and money. That is why resource allocation becomes very easy when you work with Dockers, as Docker tells us that containers share the machine's OS system kernel and therefore do not require an OS per application, driving higher server efficiencies and reducing server and licensing costs. And if you can run Docker in one platform, your application containers will run anywhere that you want. So the headache of the platform becomes obsolete. Yeah, almost 95%. But when it comes to using virtual machines to host applications, you basically deploy your applications by creating a guest operating system, on top of which you host your application. In general development process, all this takes place in one go, as the deployment workflow will first create the VM, do the initial environment setup, and then host the application and run the services and then move on. But at one point you realize you have to create additional guest operating systems, and you feel the overhead of maintaining all these operating systems or the VMs that you have. So if I have to deploy a Flask web application on a VM, I can set up all the necessary components on my virtual machine image and spin up this VM every time I want to access this application. But if I have to provision my application to a larger audience, and if I have to scale it, there might be far more complications than what I would have imagined. And if this application has to work on multiple platforms, there has to be a certain type of modification that has to be taken care of before we can make a release. The question arises about the platform and how compatible or how platform independent your application is. So you might be building it specific to a platform like Windows, Ubuntu, or Mac OS, which might run fine locally, but it might fail in production due to some compatibility issues. And this might as well increase the cost with resource allocation and maintenance. So when you create your application and you want to share this with your boss for him to deploy and check it, and if he is using a different platform and you haven't made changes accordingly, so even though your application is good, but others are not able to use it. But this video is not about Docker is good and VM is bad, because VMs have their own advantages, so please don't take me otherwise. So Docker tells us that a container is a standard unit of software that packages up code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. So what I can do is I can create a Docker container for each of these services and host them on my Docker instance running on my machine. And we will not be having the need to rewrite the same thing again and again to support multiple platforms, which gives us portable, lightweight application deployment strategies. And I can create multiple containers, like breaking my application from monolith way of deployment into multiple microservices that can run independently without affecting the whole application, with a far better speed of application creation and deployment. And yes, you don't need to create individual guest operating systems to host everything at once. And you also reduce the resource footprint, as you don't have to pay more for maintenance and license cost. So Docker works on three basic principles. So I know principle is a very heavy word to use because there are other services that can provide you the similar feature. But having said that, the first one that we have here is build, second one is share, and the third one is run. I mean, Don't run like running, but the execution. First with build. So with Docker, you can create applications from your application code by just creating your own Docker images on Windows, Mac, or Unix operating systems. You can create Docker images using the Docker command line, and also you can create multi-container applications using Docker Compose. And if you're using VS Code or GitHub or any other development tools, Docker actually works fine with all of them. So that's a very good thing. And you can run your portable Docker images on different environments seamlessly. Like if you are working on-premise using Kubernetes, you can do that as well. Or even if you're working with cloud service providers like AWS ECR, Azure ACI, Google GKS, and many more. So you can use them as well. So once you have created your Docker images, you would also want to share it so that others can make use of it. For the same, you can make use of the official Docker certified images from the Docker Hub image repository, where you can get the Docker images for your application usage. So if you create the image, you can share it with your team so that they can collaborate by adding features or fixing bugs, and they can also create tags with the update or the current update of the image. And one more very important thing, or one more very important feature, is that you can provide role-based access control to the images so that the developers don't accidentally modify the master builds. And if you want to audit the historical activities that are being going on, Docker provides you an audit log feature, which is available for users subscribed to a team plan. So you can avail this feature by upgrading your existing Docker account to a team account to start using audit log feature. And you can also make use of other open source image repositories like Treescale, Canister, and GitLab as well, or even ECR. Yes, that's what we will work on. But before that, we need to discuss a lot more. Moving on to the third one, that is run. So with Docker, you can run multiple containers with different languages, not having to worry about compatibility issues or language-based dependency. For example, I can create a Python, Java, Node.js container running along with each other independently, because I can build them by packaging all the libraries and binaries to support the code that I want to write or I want to host. And I can run them on my on-prem setup as well as on the cloud like AWS, GCP, or Azure ACI. But if we have to write our Docker image, we need to understand the process of source code. So let's check that out. So let's suppose you are a developer working on a Flask application. So you write the code and you test it and then commit the code. Then you push the code to your repository on your dev branch, which might be on Git or SVN or Bitbucket. Post which you create your PR, which is your pull request to the master branch or the production or the test branch that you have. If the peer review went well, your code will be accepted and merged to the master branch. And if you have a CI/CD integration to Jenkins or any other tool, it will create the build for you. So this is a basic scenario. But also some designs have a multi-branch pipeline which creates builds upon merging to each branch. But just keep these points in mind, or just keep these steps in mind. So create the code, commit the code, and create the build. So I'll ask you to relate to this in the next scenario, because I want you to think Docker image as the code which you will have to store in your repository. Okay, so what is repository then? So as it is mentioned here, a software repository, or repo for short, is a storage location for software packages. So it's not that you only store source code in the repository. You have repositories to store source code, RPM, packages, SDKs, image file, Debian or tar files, zip files, and as well as Docker images. Yes, that's right. So you must be using GitHub to commit your code onto your repository, and you might also be adding tags to your commit. Similarly, you can provide tags to Docker images so that you can make use of the specific tagged Docker image. And it has become like an oxygen for us developers, because you can store your code or binaries in the repos or the repositories securely. So if there is any bug, you can rectify the same without losing the previous state of the code. You can push your data as well as pull the same to work on the code or image that you want. And it's not that you only have public or private repositories. You can also set up local, remote, and central repositories. For example, if you want to create proxy repositories like we do using Nexus Docker and Artifactory, or as well when we use Maven and Artifactory. So if you haven't used Artifactory, then please let me know. We can create a session on that. And remember one thing, a repository is not equal to registry. I know you might be screaming out loud thinking about that, but just keep watching. We will get to that. First, let's talk about Docker images. So what is an image? We all talk about images, right? So what is an image? When we think in terms of virtual machines, it acts as a template for creating new instances or virtual machines. And in terms of photography, a photo is an image created by light falling on the lens or the photosensitive material. Or it's an artifactory that depicts the visual perception of how a thing looks like. So when I ask you to imagine, tell me how the mountains would look at the sunset. So your brain actually creates an image of the scene depicting a mountain at the setting sun. And this image that you have can be used as an answer if suppose you are asked this question again and again, because you have that image in your mind. Okay, I hope you got the point. So think in a way that an image is a focus point on how your container should behave when it runs. And the same image can be used to run multiple containers having the same behavior. So an image is a read-only template with instructions to create a Docker container. That's as simple as it can get. So when you write your Docker file, you add the instructions steps by steps so that they can be executed in the same sequence that you want them to. So every Docker run produces a series of layers that ultimately form the image, just like this. So each layer that you have here corresponds to certain instructions in your Docker file, and each layer that you see here is also called as intermediate images, because if you change your Docker file, it will build the layer that was changed and the ones after that while building the Docker image, thus getting the name as layer caching. We will get to this in the demo, don't worry about that. Let's move on. So there is a bit of confusion when someone says image versus containers or Docker containers versus container image, but you should not get confused here. I'll give you a small example. So let's suppose you're playing computer games. So the disk that you see can't run on its own, isn't it? So you feed it to the disk drive and then it gets installed on your computer and then you enjoy the game. Quite simple, isn't it? So if your friend wants to play the game, you can give him the disk and he or she can also install it and start playing. And if you consider the disk to be your Docker image, and when it runs on the Docker engine, it actually becomes your container. So your Docker image in runtime on Docker engine becomes Docker container. So if your Docker image is a template, then your container is the working platform or the service created based on the steps you provide. So as it is rightly mentioned here, container images become containers at runtime, and in the case of Docker containers, images become containers when they run on Docker engine. So you have the steps here. When you run them as a Docker image, you create containers. Now let's talk about one of the most important things, the Docker architecture. So let's talk about that. With Docker, if you want to build, pull or run Docker images or perform operations, you make use of the Docker client that gets installed along with the Docker desktop application that you have. And Docker client has multiple interaction points to send instructions to the Docker daemon, such as by using Docker CLI or by using Docker remote APIs, which helps us execute command and perform operations like Docker build, which creates your Docker images. Docker pull, which lets you pull Docker images from the Docker Hub or other repositories. And the last one is a Docker run, which helps you to run the image and create your Docker containers. And this can also help you, or the other commands that we have also can help you to delete the images, stop containers, or even run Docker compose. So the Docker host helps us by providing an environment where we can run our applications by giving us a package that consists of Docker daemon, Docker images, containers, networks, and storage. Then comes Docker Registry, which provides you space to store and retrieve Docker images, which we already spoke about just a few minutes back. So you can do a Docker pull where you can retrieve the image that you want. You can do a Docker push where you can push or send your image that you want. And also you can use the Docker run where you add the image file that you need to work with and you run that using the Docker registry files that you have. But for now, keep your focus on build, pull, and run. So let's see what happens when we perform these operations. When you run the Docker build, your objective here is to create the Docker image with the Docker file and the source code that you're currently working on. So you send the instruction with the name and the tag if needed, and Docker creates the image for you. If the image that you have does not exist locally, you can pull the Docker image that you want from the Docker registry, that is the Docker Hub, or any other private or public repository. Now, the image that you want is in your Docker host. And once you have the desired image in your host, then you can execute them by using docker run and create the container. So I'll repeat this once again. When you run the Docker build, your objective here is to create the Docker image with the Docker file and the source code that you're currently working on. You send the instruction with the name and tag if needed, and Docker creates the image for you. If the image actually does not exist locally, you can pull the Docker image that you want from the Docker registry, that is the Docker Hub, or any other private or public repository. And now the image that you want is in your Docker host. And once you have the desired image in your host, then you can execute them by running docker run command and create the containers. I hope this was simple enough. Let's move on. Finally, let's talk about AWS ECR, or Amazon Elastic Container Registry. Share and deploy container software publicly or privately, and that's the overall idea of using AWS ECR. Sharing and deploying container software publicly or privately. So ECR is a fully managed container registry that makes it easy to store, manage, share, and deploy your container images and artifacts anywhere. Remember that it's a registry. You're not creating containers or running them. It's a registry. And if you're having confusions between registry and repository, understand this. A registry or Docker registry or ECR is a service that is used to store and manage images. So you have to understand that in your registry, you can have repositories for your services and applications. Like if suppose I'm working on Ubuntu, I can have a repository for Ubuntu, Python, Redis, and others. But on the other hand, a repository is a collection of different Docker images or images with the same name, but which have different tags. So if you have a registry that has a repository of Ubuntu, then within the Ubuntu repository, you can place the different versions of Ubuntu that you have created. So imagine you're working on a Node.js application. You can create your repository and add images of the different version of your application in the repository by attaching tags to identify them. So you can attach tags to identify them. Like it could be 1.0, 2.0, or in the way that we give like latest or master or golden release, you can tag them by the name that you want. And ECR is a fully managed container registry that makes it easy to store, manage, share, and deploy your container images and artifacts anywhere. So I hope you're getting the point here. So you write your code and you create your Docker images. Then you create your repository for your application on ECR and you push your Docker images into ECR. And on ECR, you get the option to secure it by encrypting it with KMS. And as well as you can manage the lifecycle of your image. And once you have your image on ECR repository, you can pull them to run it on the on-premise location that you have, or you can use EKS or ECS, that is Elastic Kubernetes Service, or Elastic Container Service, that is on your cloud service provider. So I hope you got the information needed for ECR. Let's move on. So now it's time for the demo. Please pay attention to this. So this is a very simple application that I've developed. This is for user registration. So if we talk about user registration, that means that there should be a form where users can actually register to the application or the website. So we have a drop down here where basically you can click on the register button and you'll get a form. So where you can actually provide the details. Let's suppose frank@abc.com. Course is AWS, profession is software, company is ABC, and earning, let's suppose, is 12324. And you can just submit the query. So once you have submitted it, it will come down and it will be listed at the end of the table entry. So this is basically a simple user registration app. And for this, I've used Flask that I've already mentioned. Like I've used Flask and Postgres to store the data that I have. So this is the PG admin console that I have right now. So if you go here, you see user registration within CourseDB. This is the database that I'm working on. So in right click on this and you can create a select script, and then you can just basically run it. So you will see all the values that are being populated here. But the main objective for us is to not learn Flask or learn about how I have integrated Flask and database. The main objective for us is to migrate this application that I have to Docker, isn't it? So that's what we are going to focus on. But don't worry, I will be giving you the code and I'll share the GitHub link where you can download the code that I have right now, and you can also execute it and learn more about it on how the integration has been done. And if you are well versed with this, then you might be able to do far more better than what I have done, because I've just spent like an hour to do this. So this is what I was able to get. And if you want to customize on your own, and if you want to build something beautiful, then also you can do that, and you can share this with me on what you have done and how your experience was. So moving on. So this is my app.py where my application is running right now. So the basic idea is basically to import the database URIs that are the connection parameters that we are going to use. And in Flask, you have to just create an application. If you want to configure that, you can do that by using app.config. If you want to enable the debug mode, you can do app.debug equal to true. And using SQL Alchemy, Flask SQL Alchemy, I am going to create the model. So this is my basic table. So if you see here, user registration, if you go back, you will see the table being created here. So if I run this, what happens is it creates the model for me. So everything that you see here, the ID, you name, you email, you course, will be a column here. And the type of data that I want to give, or I want to set the data type, I can give it here. And I want to make ID as the primary key, and I want to make the email ID as to be unique and nullable equal to false. So all the values that we have here are mandatory anyways. So in that sense, I am able to create a particular schema for myself so that my data can be populated here. I'll just close this and I'll just type app.py. So now what happens is it is running the application on 192.168.0.116, and the default port that I have is 5000, but you can change it, but I don't have any problem. I can keep it at 5000. And one more thing that I've done is I have created like, let's suppose the database already does not exist. So I have written a function which basically will create the database for me. And the value that I'm trying to find here is from the utils file. So I've created a utils file where I am giving all the necessary configurations. So this is how you configure in the real-time scenario as well, where you don't want to have hard-coded values in your code, but this thing actually will not be here in your code. It will be somewhere else that you want to, or that you will be pulling information from. So don't worry about this, but having the hard-coded values in your code is not a recommended solution. So make sure that you have a utils file or a credentials file where you can pull information from. And based on your security levels that you want to have, you can have different mechanisms already available. But for now, this is a very simple example, so I don't want to stretch on this one. Just I want to show you that what are the features that are available to us, or what are the methods that I have applied. So now what happens is the next thing that I want to do is basically to create the Docker image for my Flask application. The next thing that we have to do is create the Docker file so that we can migrate our application that we have to Docker. To save the time, I have already written the Docker file that we have. So this is the Docker file that I have written. So I'll just explain you the steps here and why I have written all these things so that you get an overall idea of how the Docker file actually looks like and how it exactly works. Then we are going to create an image so that you can see how the image build is, so how the image is created, and then we'll host the containers by using Docker Compose. So don't worry about that. We'll do that one by one. So here, as you can see, I have written the Docker file, and this Docker file that you see here is present on my base folder path, where my app.py is also there. So the first thing that I've written is from Python 3.7.11-alpine 3.13. So this basically sets the base image for the instructions that you're going to write. And mostly all the Docker files actually start from a from statement. So here my base image that I'm going to take is 3.7.11 Python, and Alpine, which is basically the Linux distribution. So this is going to be my base image. On top of this, whatever instruction that I write will be executed. And the next thing is env install_path/postgres application. So this will create the environment variable as install path. and I can use it across my Docker file. So the next thing that we have here is run mkdir-p install path. So this will create the folder path for my image. So the code that I want to store on the image, it will create that path for me. And then I'm going to change the working directory to the install path that I've just created right now in this step, run mkdir-p, so that all the operations that I take or I perform will take place at this particular path. So this is similar to like chdir. And then what we have is we can copy the requirements.txt file. So copy is a command which basically takes two parameters. So we have the source path and the destination path. As we already know that the source path already has the same path itself as requirements.txt. So the requirement.txt is already present on the base path. So that becomes my source path, and the install path is my current working directory. So I can just paste it here. Then what I'm going to do, I'm going to install or upgrade pip that I have using pip install --upgrade pip. And then I'll add a few Python upgrade steps and I can execute them on the container using the run command. So now at this step, I have upgraded pip and I have installed psychopg2, which I will be using for the Postgres database integration, with my code, the Flask code that I have. And then I can run the requirements.txt, or I can install the packages that I want for my application to work. So those packages are already present in requirements.txt, so I'm good with it. So I can just run this step and all the packages and the modules that I have will get installed. And then I'll just remove the APKs that I have just to reduce the file size or the image size that I have. And then I can copy the source code. So that is what I will do next. So next I want to copy the source path to the destination path. So everything that I have on the source path should be copied to the destination path. So as the current path is the source path and the destination is install path that you have, that I created right now, I can use copy dot dot. So the first dot is for the source path and the second dot is for the destination. And what it will do, it will copy all the contents in my source path onto the image, that is the destination path. So now that we have all the dependencies installed and we have the source code copied as well in this step, now we can set the entry point. So I'm using the Docker container as executable, and I want the first thing to run on the container to be Python. And along with that, I want to run app.py, and that is my main application file, so I can start the application. So that is why I'm creating the entry point as Python, and I want to run app.py. And some of you might be saying that, Ari, you are using both entry point and command. You can write it in one line. I know that. Don't worry. I have used command so that I can modify and run any other command. And if I want to run it in runtime later, so I can do that. So that's the only reason that I'm doing it. So just chill. You can do that in a single command or a double command. There is no problem with this. This is just an example code or the example Docker file. So this works fine, and this is the standard way to do it. So don't worry about this. So now that you have written the Docker file, the next best thing for us is to run this Docker file and create the image, isn't it? For that, you have to start your Docker that you have already installed by watching the previous episodes that we have, where we have already told you how to basically install Docker on Windows. So you can just follow this, and so you can follow that and you can install Docker and you can start the Docker application. So in order to build the Docker image, what you're going to do is you're going to use the build command. So in order to build the Docker image, you have to use the build command. How convenient is it, isn't it? So docker build -t, and then you can just provide the name of the image that you want. But before that, I want to check if I have any images already there. No, so we don't have that. So you can just type docker space images to see if you have any images or not, or you can just type -a as well to see more about that. So now that we don't have any images, we are good to go. So docker build -t Flask app, there's the name of the image that I want to give, and then give the dot. So this will be the Docker file path. So currently my Docker file resides in the same folder path or the current working path that I am in. So whenever I'm running this command, it will look in the same folder path. So if you have your Docker file in any other location, you can provide the path for that. But for now, I am running in the same location, so I can just give a dot. So don't worry about that and just hit enter. So as you can see here, it is running the mkdir. So it is going to create the folder path on the image, and working directory, it is trying to change it. Then it copied the requirements.txt file, it upgraded pip, and it installed psychopg2. Then it installed the requirements.txt, then it removed the apks, then it copied the source code, and now it is done. And as well, you can use docker scan to run sync tests against images to find vulnerabilities and learn how to fix them. So if there is any package that you're currently using in your Docker image that is not proper and it has vulnerabilities, you can just run a sync test. So don't worry about that. We are not going to face anything like that in our code because we are using proper packages. So don't worry about that. I'm just kidding. You can just make sure that you do this whenever you feel like. Okay, so I just ran a docker images command to see if my image has been created. So okay, so it is created about a minute ago. We can refer to this image using this image ID or the name of the particular image, and the tag that we have here is latest because I did not give any tag name when I was creating this image. So if you see here, this command does not have any tag. So if I want to give tag, I can just put a colon and I can give a tag like 0.1 or 1.0, or I can give it like master, or I can give it like 5.0, like that. So the next thing that I want to do is I want to run this Flask application. But remember one thing, this Flask application basically uses the Postgres as well. So if I run this, it will not be able to connect because there is no container which is already running with the Postgres installed. So that is what I wanted to show. Like if you have a multi-container architecture, then you need to have a placeholder where you can place all these services together and host it at once so that you can launch the application at once. And that is where Docker Compose actually helps us. But before that, I'll just run this and I'll show you how it actually breaks down. So if you want to run this image, then you can just do a Docker run and Flask app. You can just give the name. And there are other ways actually, or other parameters that run uses. You can check them out in the documentation. But for now, just to keep this simple, I can just do a Docker run Flask app and I can just hit enter. It is currently expecting the 5432 port to be connected so that it can work, but we don't have that running. So the next thing that we want to do is we want to host the application at once. So for that, I'll write a Docker Compose. So Docker Compose basically will allow us to host a multi-container application by writing all the services that we need at one place. And I have already written the Docker Compose file. I'll just show you how I have done it, and I will give you this file as well so you can play around with it, enjoy with it. Okay, so don't worry about that. So in Docker Compose, so if you see here, I'll just lower this down. So the first thing that you see here is version. So the current version for that Docker Compose is 3.7. So this is basically your compose file format. So that is 3.7. And then I can mention all the services that I want. So I have Flask app. So the image that I want is Flask app. So I can write, this is the first service that I have. So the Flask app is basically going to provide me the application that I want to run. So all the code that we wrote for the Flask application will be covered here. So this will be the service for me where I can host my Flask application. So Flask application takes image as a parameter. So already we have created a Flask app image, and ports basically is 5001. This will be the external port and this one will be the internal port. So here actually the confusion always is that what exactly is what. I'm sorry, like what port actually denotes what. So if you see on the left hand side, we have 5001, isn't it? And on the right hand side, you have 5000. So when I explained to you about the application, the Flask actually runs on 5000, isn't it? So when the container comes out or container gets created for this particular Flask application, I want the external port to be 5001 and the internal port to be 5000. So if I launch the browser, I will use 5001 to connect to this particular port number for this particular application. So let's suppose this application gets created and it is at 127.0.0.1. Then if I use :5000, it will not work because it is not running on that port right now. So I have to use an external port that is basically attached to my internal port that I have for my Flask application. So I will be using 5001. So on the left hand side always remember that you have the external port, and on the right hand side you have the internal port. If you have any other ideas, then you can put that in the comment section as well. And if you see here, we have environment, and here what I have done is I have given the database URI to be this. So my utils.py is going to take the environment variable from this, but I've already given the default value. So if it does not provide also, it will take it. So don't worry about that. But for safe side, I'm just giving it here. So don't worry about that. It will take it whenever it wants. So I can change the values as well if suppose the values changes. And then I will host my service, that is Postgres. So for Postgres, we don't need to create any image independently. We can just pull the Docker registry image that we have for Postgres for the 13 version. And I want to keep the external and the internal port as same. So 5432 will be fine. And I have placed a health check where actually it checks for the command shell. So if Postgres is ready or not. So for every 30 seconds, it'll check if there is a timeout for about 10 seconds, and it'll try for 5 times. And if that fails, then it'll fail the container. And then I'll attach a volume for this, and the environment variable will be for Postgres will be Postgres user and Postgres password. So Postgres and root. So there's the username and password that I have right now. So if the health check actually fails, what it is going to do is it is going to restart. That is why I've written a policy where basically it tells us on failure, it should restart. And as I had pgadmin on my local to view the data that I have, but on the container side, I may not have it. So what I'm going to do, I'm going to use a GraphQL engine. And if you don't know about GraphQL engine, you can just see the database schemas on the application that you're currently working on. And you can just integrate this with the database that you have. So currently we are using Postgres on 5432. So what I'm going to do is I'm going to provide the same URI that I have, database URI, to this particular Azure GraphQL database. And it'll pull the data from here so that we can see the schema using GraphQL. So this is one of the most interesting thing that I wanted to show you for this demo. So don't worry about this. And then we are just provisioning the volume here that we created to Postgres. I know that you might be thinking that it is a very rushed out session, but I just wanted to talk about ECR, but I have stretched this session to give you a demo so that we can understand how we actually work on migrating applications using Docker. And then I want to show you ECR as well. So it'll take a lot of time. So please forgive me that I'm not explaining each of these steps in detail, but I hope you understand that this is not intended for Docker. This was basically for ECR, but for better understanding, I'm just telling you all these things so that you can also learn from and benefit from this. So if you have any doubts, then you can just put them in the comment section below. But anyways, we are going to work on Kubernetes in the next session. So this will be covered there as well. So don't worry about this. Just see how it is actually working. So now that you have your Docker Compose file, what you can do is you have to actually run it, isn't it? So for that, what you can do, you can just type Docker Compose. Okay, Docker space compose up. We're going to up the composition that we have in our compose file. And then we're going to just run this in a detached mode. So -d and just type enter or hit enter. So it will read through all the steps that we have mentioned here on the Docker Compose file, and it'll create all the containers that we want, and it'll host the application at once. Okay. So now as the Docker Compose file has run, it has created the network default, it has created the volume, so it has created the Postgres container, it has created the Flask app container, it has also created the GraphQL engine as well. So there are a lot of things that have been created here. So first thing we are going to do is I'm going to just check the Docker images -a. So now that you see, we have 3 images that have been created, and now I want to see the containers. So in order to see the containers, what you can do is you can just type the process here. So docker ps -a, and you can see, I think the application is running somewhere. I'll just check. It keeps on restarting. So what I'm going to do is I'm going to stop the pgadmin that I have right now that is running here. And now what I'm going to do is I'm going to run the Docker Compose up again. Okay, just run this once again. Okay, so now it is running, and if you see here, health starting, and is up 7 seconds ago, 8 seconds ago, 8 seconds ago. Just do a docker ps again, So now this is good for us. So I think the pgadmin that was running on my local was the issue. So I'm a bit stupid in that case. So here what I can do is you can just use the 5001 port, and I'll go to the browser right now, :5001. Yes. So on 5001, if you see, we are having the application and there are no entries that are found here. So if we have to validate that our application is working, then we have to register it, isn't it? See, it is running on 5001 as per the container that we have here. So externally it is trying to access 5001, but internally it is trying to reach out to 5000 port on the Flask app. So here if you see, we have the containers. So this is the container ID, this is the image ID that is going to be used, that is it has been using, and there's the entry point python app.py, and this is the created time, this is the status, this is the port number that are being accessed right now, and there's the name of the container that we have. So now what we can do is we can just add a few entries. So sam@abc.com, AWS software ABC, and earning will be okay. So we can just run this query, or we can submit this and it should work fine. Yes, you can see it is working fine for now. So now what we can do is we have installed GraphQL engine, isn't it? So let's see how that actually works. So you can just copy this 8085. We are having that on the port 8085 port number. Then you reach here. Okay. So this is the GraphQL database. And here you can find your schema that you have created. So you can go to data, and here you can see the untracked tables of users, isn't it? So here we have a user registration table. So you can just click on track. So it will list you all the properties that it has. So now if you click on browse rows, it will show the data that you have. So it's a very good and interesting way to as well view your schema that you have, isn't it? So now the application that was running on a particular local machine, we have translated that into Docker, and we are able to use it using the Docker containers that we have. For now, we'll go back to the AWS console and we'll create a repository there. Okay, so now we are here on the AWS console. So we have to go to ECR. So you can just type ECR here and go to Elastic Container Registry, or as well, if you have already visited, you can just click on this Elastic Container Registry here. But for now, what we're going to do is we're going to go to the search option and we are going to click on AWS ECR. So once you click on this, I've already created this one. So I'll just remove this. Just remove this. Okay. So as I told you that this is a registry and we can create repositories in this one. So I'm going to create a private repository so that I can push my images that are private to myself. Okay. So now I don't have any repositories, as you can see here. So what I'm going to do is I'm going to create a repository. So this is the private repository setting that I have. And this actually you can do it using the command line as well. But for viewer's perspective, and if you want to understand it better, if I run a command, then it will not be understandable to many of you. So I just wanted to show you in this way as well. But mostly in organizations, we don't use this UI. We just go with the CLIs because that are more convenient, because you can automate that. So here I have the private enabled for me, and I don't want to make it visible to public. So this will be private for myself. And this is the image ID that I will be having. This is the precursor name for my image, and I can add Flask app as my image name or the repository name, because that is my application that I'm working on. So similarly, I can create a Flask app or the GraphQL app repository, but I'm not working on them because I'm not customizing any of that. I'm just using it. So the only thing that I want to protect is my Flask application. So I'll only create the repository for that, because using the Docker Compose, I can pull the Postgres and GraphQL builds from the Docker registry as well. So I don't need that. I just need for the Flask application. So tag immutability. So here actually you can enable tag immutability to prevent image tags, subsequent images using the same tag. So disable tag immutability to allow tags to be overwritten. So what happens is if you have a tag like Flask app :1.0, and if you push it again with the same tag, then the existing one that you have here will get changed. Okay. So once the repository is created, the visibility setting of the repository can't be changed. So make sure that you have mentioned it properly while creating itself. So I don't want this option, let it override. This is just an example, so don't worry about that. And as I told you, you can also have the image scan in place where you can actually enable it so that it can check for the vulnerabilities for the images that you have, if they are using any packages that are vulnerable. You can just enable this, and you can as well do the encryption of your current images that you have. So you can enable the KMS, and here you can provide the KMS keys that you want to provide, or else you can disable it. So for now I will disable it because I don't want it. And once you have done all these settings, you're fine and you're good to go. Then you can just click on create repository. So now that I have created the repository, you can see the repository name being mentioned here, and the URI is very important because that is something that we are going to use to create the build, and we are going to push it as well using this particular URI. So remember this, or you should always keep note of this one. And it was created at this particular time, and the tag immutability is disabled, and scan on push is disabled. Otherwise it takes a lot of time basically if it starts scanning everything. So I have disabled it for now, and the encryption type is basically AES, so it's okay. So it's the default encryption that we have. And now what I can do is, if I want to change something, I can go to edit. Okay, so this cannot be changed once a repository is created, and this cannot be changed once a repository is created. That is why it was already mentioned that you can enable this or disable it before creating the repository. So if you want to enable this again, delete this and create a new repository. So that's one thing that you need to understand. So once you click on this repository that you have created, the best thing about AWS is it provides you all the commands. So if you click on view push commands, you get all the information that you want. So if you are on Windows, you can follow this, but if you are on Linux or Mac OS, you can follow this one. But I am using PS or PowerShell, so I can use the same commands that we have here. So I'll go back to the terminal that we have. If you see Docker images, we have these images, right? So the first thing that you have to do is you have to log into ECR. So make sure that you have configured the AWS credentials for your command line. So for that, you need to install Python AWS CLI. So you can install it using pip. So if I do a pip freeze here, I can just show you. So I have installed AWS CLI. So this is what you need to install to configure your AWS. So if you type AWS configure here, so you will get the option to basically add your AWS access key ID that you get when you create your AWS account. So please have them handy so that you can actually provide them. So you can provide the AWS access key ID, the secret key, the default region name, the output format, that is JSON for me. And you can just add or associate all the credentials that you have so that your Docker commands or the AWS ECR commands don't fail. So now that I have already copied the command, so I can just paste it here. So this is the ECR login command. So we have AWS ECR get login password -region. That is the region that I have, AP South 1. And on that, basically it takes the Docker login. The username is AWS. The password will take from the standard input for this particular user. So now you can just hit enter. So if everything works, then you will get the login succeeded. And now you are good to create your build for your particular repository. So for that, you can go back. So as I've already written this step, or we have already created the Flask app, the next thing that I want to do is I want to create the build for my repository or the ECR repository that I have. So for this, what I can do is I can tag the image that I have right now. So Docker image that I have right now, Flask app latest, to this particular path. So this will be the repo URI, and this is the particular repository that I have with the latest tag. So if I tag this, it'll create a build with the same tag so that I can show you. Like I'll just hit enter here. So once you have entered the tag here, you can just go back to Docker images so that you will see a tag that is being created. So the same Flask app with the same size is being created with a latest tag, but you see the name is different here. Okay. But if you want, you can basically change the tag as well on this one. For the latest that you have right now here, you can push it as 1.0. So not a problem. So don't worry about that. You can do that as well. Okay, so now that we have tagged this, so the next thing that we can do is we can push it. So you can copy this command and you can just type docker push. So this is basically to push your Docker images onto the repository that you want. And this is the latest tag that I want to push for this particular Flask app image. So now that we have this command already ready with us, just hit enter and it will start pushing. Okay, so it took some time, but it is pushed now. So it's a good thing for us. We can go back to the console that we have and I'll just close it. You can just refresh it once again and see. So now that you have the digest here, you can just compare it with the digest that you have on the console. So 98651C. So 98651C. So the same one. And there's the latest image that we have for Flask. So here only you will get the tags. So it's just like committing your code and providing tags to that. We can go to the public gallery. So there's the ECR public gallery. You can share containers, images publicly and privately here. So you can find all the Docker images or the images that you want from here and you can use them as well. So just like I was using Postgres, I can just see if I have a Postgres here. See, I have a Postgres here as well. So I can use it. And if I wanted to use GraphQL, yeah, I have it. Hashura GraphQL. But the most important thing that I wanted to do was I wanted to pull this image, isn't it? So for that, what I can do is I can just type Docker images and we have this image, isn't it? So I don't want this image now. So I'll just clear this. So I'll list the Docker images here. So if you can see, we have 4 Docker images, but as you can see, this Docker image is not created again. It is just using the same reference ID for this, the image ID for this, and it is just trying to have its own image file here. So what I can do is I can just remove this. So for this, what I can do, I can just do a Docker images or Docker image rm. So remove, and then I can just copy this and I can paste it here. So now it will be untagged and it will be removed. Okay, so we have removed this, but don't think that it will be removed from the repository as well. It will stay there. So now that I want to basically pull this image, I can just copy this URI and do a Docker pull. But remember, even if you want to do a Docker pull, if your session has been completed, so once you come back to the terminal again, you have to log in with the AWS credentials and then only you will be able to pull the image. You have to log into AWS ECR using the credentials that we previously checked, and then you can do a Docker pull. Okay, so now we have the image. So now what I've done is basically I have stopped all the containers that were currently running for my application. And now what I'm going to do is I'm going to change the Docker Compose file and we will use the image that we have, not this one, but from the AWS ECR. So for now, you can just type Docker images and you can see we have all the images, right? So currently these are not in use. So these two are not in use right now. So I can delete them and I can do a Docker images rm and I can paste it and I can delete it. Docker image rm. So now what happens is I'll just delete that Docker image rm and I'll just delete this for now. So I'll just check the status once again. Okay, sorry, it is not able to remove it. So I can just force delete, I think. Okay, so by using rm-f, I can just force delete that and I'll check the images once again. So currently we have only 2 images. Now you can see that the Docker images that we have here is the GraphQL and Postgres, and we don't have the Flask application right now. So now what I can do is I can just pull the image that I have. So I'll go here and I'll go to the push commands and I'll copy this and I'll just paste it here. And for this, what I'm going to do is I'm just going to pull it. So it should pull the image for me from the AWS ECR. Okay. So now what you can see is with Docker images, you can see we have the image here. So whenever you are creating a Docker Compose or launching applications using Docker Compose, so if you want to bring down the whole container application, then you can just do a Docker Compose down. So now what I'm going to do, I'm going to place this as I've already placed it. So :latest. So I'll just remove this. I don't need it right now. So here I'm just going to do a Docker Compose up -d. So if you see here, we are using this image that we downloaded from the AWS ECR. So I can actually place this here as well and run it, and I can show you it in the next episode. But for now, I'm just going to use it by pulling it directly onto my local host, and then I can just add this image name here, and I can start the containers using Docker Compose. So if I go back to Docker PS, then I can see the applications are running. Okay, so this is working fine for me. And now what I can do is I can bring down the whole container set that I have. So Docker Compose down. So it will stop everything that you're currently running on. Okay, so now what you can do is, if you want to confirm, then you can do a Docker PS-a. It should not have anything. So it's very simple, isn't it? So now we have used the image from our private repository, not from the local one. So we pulled the image and we have used it. So now it's time for your task. So first thing, clone the repository and set up the environment as per the video that we have seen. Next, install Docker and create the build, and using Docker commands, launch the application. If you want, you can run all the Docker commands and read more about them in the documentation. And please, once you're done with the application that you have and creating the Docker image, push them into ECR by creating your repository. And then your task is to comment on what you have learned and if you have faced any issues. So if you have any issues, please let me know in the comment section below. And based on your feedback, I have changed the formats of the videos. Please let me know if you like it. If you did, please make sure that you hit the like button, because it will tell YouTube to push my videos and help my content reach a larger audience. So I'll meet you in the next one. We will discuss about Kubernetes. So please make sure that you join me in that as well. So until next time, stay safe, stay healthy. It's Pythoholic signing off.